And you already know what comes next. It's time for some tests, but look at how fast we're going here. So basic NFT test.t.sol. Once again, same business, SPDX, license identifier, MRT, Pragma Solidity 0.8.18, contract, basic NFT test is test. That means we're going to have to import test from forge std/test.sol like this. In here, we're going to need our function setup. This is going to be public. We'll make a deployer. We'll do a deploy basic NFT deployer, say public deployer. And then we'll also have a basic NFT, public basic NFT. Up at the top, we're going to do import deploy basic NFT from /src/script/deploy basic NFT.s.sol. Import basic NFT from /src/basic NFT.sol. What do I do here? Deploy basic NFT.s.sol. Oh, not here. There we go. All right, cool. So now we're going to say deployer equals new deploy basic NFT. Basic NFT equals deployer.run. Looks good. And let's write a test. So we're not going to write all of the tests here, but I do highly encourage you to pause the video after we write a couple tests here, and you continue and write some of your own tests. So let's start here, and let's just make sure that the name is correct. So the name here we have is doggy and dog. Let's go ahead and write a test to make sure this name is correct. So we'll say function test name is correct. This will be a public, and I know this is going to be a view function, so I'm going to do view. And now here's where we run into our first issue. So string memory expected name is what? It's going to be doggy, right? That's the expected name. And the string memory actual name is going to equal what? Basic NFT.name, right? The OpenZeppelin package that we imported, if we click into it and we click into this, we scroll down, there's this function name down here, which just returns the name, right? This is a public view. So we know it has this name function that we can call. So in our test, we could do basic NFT.name. But if we do assert, well, assert equals or assert and do the equal stuff. Actually, let's do assert. We can't do expected name equals actual name. If we do it, we get this little red squiggly line that says built-in binary operator equals cannot be applied to types string memory and string memory. And why not? Well, remember how we said strings are a special type, right? Strings are an array of bytes. They're a bytes array, right? And with bytes arrays, we actually can't compare arrays to arrays. We can only compare primitive types or elementary types like a uint256, a bool, an address, bytes 32, etc. Right? We can't compare array of bytes, which means we can't compare strings since we can't compare arrays. So how do we make sure these strings are the same thing? Well, since it's an array, we could do like a for loop and loop through the array and then compare the elements of the array, right? If it's an array of bytes, let's say it's an array of bytes 32, right? Bytes 32s we can compare. So why don't we just loop through and do that? Well, we could, but to be honest, that's kind of too much work for us. we want an easier way to actually compare these things. Now, what we could do is we could do this thing called abi.encode, pack the entire array and take the hash of that. Remember what a hash is. A hash is a function that returns a fixed sized unique string that identifies that object. So if we hash these arrays, that would be an easier way to actually compare the two of them. We would just compare the hashes instead of looping through the array, which is going to be a lot more coding and it's going to be a lot more verbose. So this is something, again, where your whatever AI buddy you're working with will probably get this right. We ask them, how can we compare two strings in Solidity, or strings, I should spell correctly. ChatGPT and hopefully most AIs are actually able to get this for you. Hey, strings are more complex types. They're essentially dynamic arrays, yep, and therefore can't be compared directly with equals. So if we scroll down, they're doing something similar. They're converting the strings to bytes and getting the hashes of that. That works too. We're going to convert them to bytes using ABI encode packed. Now, this is where I will often use a tool like Chisel, which comes built in with Foundry, to help me get a good idea of what I'm doing makes sense, right? So what I can do is I can say string memory cat equals cat. Say string memory dog equals dog. If I type in cat, I get this crazy weird output that looks like this, but this is kind of the hex of this cat, if you will, right? What I can do is I could say bytes memory encoded cat equals abi.encode packed cat. And now I have encoded cat, which is of type dynamic bytes. And now we have a bytes object. We can actually hash a bytes object. So we could say bytes 32 cat hash equals kit check 256 encoded cat. And now we have a cat hash, which is just a simple bytes 32. So we can convert our strings to bytes and convert the bytes to a bytes 32, and we just compare the hashes of both of those. So we'll hit Control C twice to exit, clear the terminal, and let's use that methodology here. And I know I haven't explained this abi.encode packed yet, but I will very soon in this lesson, I promise. So for now, just kind of think it's magic, all right? But I promise I'm gonna explain it very soon. So what we can do is we can do assert kitchak 256 of the abi.encode packed of the expected name is going to equal kitchak 256 of the abi.encoded encode packed actual name. And I'm going to open up the command palette, do toggle word wrap here like this. And this is how we can actually compare the two strings by encoding them. So now if I pull up the terminal, forge test-m, test name is correct, or just forge test, boom, we get this indeed passes. So this is how we can tell these two names are the same. If this was something like Toggy, and we ran this now, you're gonna see that it's gonna fail. Fails. Great, so let's bring it back to Doggy. Awesome, so we have a way to actually test if these strings are the same. Great, let's write two more tests. So we'll do function test can mint and have a balance. Make this public. Let's create some user. So back up at the top, we'll do address public user equals make addr user like this. We'll make a user. And down here, we'll prank them, bm.prank user. And we'll do basic nft.mint nft. And this is where we're going to need to add some token URI. And this is where I'm going to recommend we come over to the GitHub repo associated with this course. And let's, for now, just grab an IPFS hash to use. So we're going to say string memory. Actually, let's just do this at the top. String memory public constant pug equals, paste it in here. Oh, sorry, not memory. Obviously, this is a storage variable. And then if you want to, I recommend you trying to upload your own metadata file to IPFS. Remember, it needs to be in this JSON format with a list of attributes. And then the image is going to be its own file uploaded to IPFS. And then you're going to take that and put it in the image section here. Definitely recommend you guys trying it out. But we have this pug. We're going to use this down here, mint NFT pug. And then we can do a little assert. We can say assert, first off, basic NFT dot balance of user is going to be equal 1. And we can also do a little assert. We can make sure that the token URI of this NFT is this pug, right? So we can say assert, and this is where we do the kitchak 256 again, abi.encode packed pug. It's going to be equal to kitchak. Oh, it's just K. I don't think it's CK. 256 abi.encode packed basic NFT.token URI 0. Ooh. All right, let's try this one. Let's just do forge test. Let's run both tests. And we did it. Okay, awesome.